So for section 13.2, we're going to go ahead and look at conic sections. This used to be 13.1, so in a second it's actually going to go into my old video where it says 13.1, but it's still pertinent. All of this should apply into 13.2 section, so don't freak out about that. And there's a little bit more on this than you need, but it should kind of tie together all three of these type of conic sections. The circle and the ellipse and the parabola are all things that you're going to need to know for the upcoming test and for the final.
When graphing conic sections, there's really just several types that we need to be familiar with, but they all use the whole idea of H and K and things shifting. So we are going to have circles, which the basic form of that is x squared plus y squared equals r squared. It'll be shifted H and K with a radius of r. We'll talk about that as we keep going. We will have ellipses where it's x squared plus y squared and a squared and b squared. Ellipse is basically an oval, so if I cut the conic or the cone, if I cut it at an angle instead of getting a circle, I get an ellipse. Okay, so I get an oval shape. And I can also have shifting on that, H and K. Same idea. And then we can have parabolas. And parabolas are if I cut vertically, I can have a parabola that opens left and down, or depending on, I could actually have a parabola open left and right. So we're going to be dealing with all the different types of parabolas, and for this section what I'm going to focus on is the parabolas and the circles. But the ellipses are just an extension on the circle, but for now let's just focus on parabola and circles. Okay? So we've seen y equals x squared before, where it's x minus h squared plus k, and our vertex is hk. In this situation, h is the opposite of them. Okay? But we're also going to see x equals y squared, which is a parabola that opens left and right, and we'll see that. But notice we still have an h and a k, but this time the h is on the outside. The h is the horizontal shift, okay? The k is the vertical shift. So when you have an x equals y squared, the number that's in here, the k, this time will be opposite, and the vertical shift is actually with the y. Up here, the h was with the x, that's the horizontal shift. If it's a number with a y, that's a vertical shift. So we're going to see that, but that's kind of the weird difference between these two is on this one the h is opposite, on this one the k is opposite. When we deal with any circles or ellipses or any other conic sections, notice the h and k are actually both with the x and the y, so they're both opposite. Okay, so parabolas are kind of the weird ones, but let's do a quick review of what we already know. If I asked you to graph this, and I'm starting with a pretty easy one, so I want to know the vertex form and I want to be able to graph it. That means we need to remember, how do I get it back into this form? We complete the and yes, I understand there's some other shortcuts to do this, but this is going to be our best bet, especially when we get to our last example. I'm going to show you where you have to be able to complete the square to get the vertices for circles and other conic sections. Okay, so our first step, we're going to move the c. I'm not going to use that 9 to complete the square, so I have y minus 9 is equal to. We're now ready to complete the square. We're just going to use the a and the b and give it a new c. What's that going to make? X squared minus 4x. How about x minus 2 squared? Remember, it's that number cut in half. If we were to distribute that out, we would get x squared minus 2x would make minus 4x, and negative 2 times negative 2 would give us plus 4. This needs that 4 to complete the square. Okay? If we add 4 on one side, do it to the other, so we end up with y minus 5 is equal to, once we add the 5, we get y is equal to x minus 2 squared plus 5. You should be able to do a sketch graph from this. First, find the vertex. So our vertex is going to be h and k. In this situation, the number that's with the x is going to be the h's opposite. So instead of being at negative 2, 5, our vertex is at 2, 5. How do you graph it from there? Well, we go to 2, and up 1, 2, 3, 4, 5. And really, all I need you to know past this, once you have that vertex, is that we have a parabola opening upward. And we said before, if we want more exact points, that we could plot a point around the vertex. So for instance, if I plugged in that 3 into the equation, 3 minus 2 is 1, 1 squared is 1, 1 plus 5 is 6. We could get 3, 6. If you needed another point, I'm more concerned for this at the end that you can just complete the square, find the vertex, know whether it opens up or down. That should be enough. Onward. Do one more warm up here. Let's go ahead and complete the square on this. So step 1, we're going to move the C over. Not going to use that. X squared minus 8x. What's our perfect square for that? How about x minus 4 this time? Those two 4's would combine to make a negative 8. They would also multiply to make a 16. If I do that to one side, do it to the other. Now this is interesting because we actually had a 16 there, but we didn't know, or we don't, it's very rare that that number is going to be the number we need for the perfect square. So as a general rule, I move it over, but technically that 16 would have worked at the beginning. Okay. So where's our vertex? H and K. We have an H. There is no K. There's no number out there, right? That 16 was used in completing the square, or that negative 16 plus 16 left a 0 there. Well, that just means our K is 0. So our vertex is going to be at 4, 0. We could sketch that. And here's where I need to know that since my A was positive, this parabola is going to open upward. If I wanted another point, I would check a point past 4, something like 5. If I plug in a 5, 5 minus 4 is 1, 1 squared is 1, so we got the point 5, 1. Okay? So I'm more concerned, again, find the vertex, know if it opens up or down. Let's keep going. That should have all been reviewed. This is not something we've seen before. So let's talk about how this would work. Well, if I plugged in x values, we could still solve for y. For instance, if I plugged in a negative 1 equals y squared, I could solve for y by undoing the squaring by square rooting. Y is equal to plus or minus square root of negative 1 is I. This is not going to be graphable, right? So in this situation, there is a restriction on the x because y squared, and I'm going to end up square rooting to solve that, I need x to be positive. There's a restriction on the domain of this function. The domain x must be greater than or equal to 0. So back here the graph does not exist. Not really. We have an imaginary number that we use for that, but it doesn't really exist back there. But we could do 0. 0 is equal to y squared. If I do the square root of that, plus or minus 0. How about just 0? Well, there's a point. Finally, what happens when I plug in a 1? Well, 1 equals y squared. If I square root that, square root of 1 plus or minus 1 is equal to y. Now this is interesting because this basically means I have 2 points. When x is 1, y is 1, and when x is 1, y is negative 1. This is not a function, but that doesn't mean we can't graph it. Doesn't mean this graph doesn't exist. It's just not a function. This x gives us 2 y values. 2, if I checked it, I would get plus or minus square root of 2. That ain't going to be pretty. So would I check 3 next, right? No, let's choose a number that's we're going to get a nice square root of. So how about if I plug in a 4, and I get 4 is equal to y squared, so that y is equal to plus or minus 2. 2, 3, 4, up and down 2. What is this graph looking like? Well, we already knew it's a parabola, right? But when I have x equals y squared instead of y equals x squared, it creates a parabola that's opening to the right. See that? So the idea is we basically end up with a parabola opening to the right when we have x equals y squared. What would happen if we had a negative in there? I don't think they do this in any of the homework, but I want you to see. So this would be a is now negative 1. Well, the same thing it did before. It reflects. But this time, instead of reflecting up and down, because we're not dealing with a parabola that opens up or down, it creates a reflection that opens to the left. I do not believe they do anything with that in the homework, but I just wanted you to see that the A still can have a reflection. It still stretches and shrinks. It has all the same applications. Our parabola just opens a little differently. Okay, so that A still creates a reflection, but this time it is across the y-axis instead of the x-axis. Onward. This is a parabola. Ax squared plus bx plus c. The problem is it is not in the right form, right? If I want to graph this, I need this in vertex form. That means I need to be able to complete the square. So, move the 9, just like we did before. X minus 9 equals, let's complete the square, y minus 2 squared. That would create y squared minus 4y plus, so this becomes x minus 5. To get it back into vertex form, we're going to just move over the 5. So people look at this and they're like, oh my gosh, this is crazy. How could I ever do this? I knew how to complete the square, but now you changed everything. Guys, this is basically the same as example 1. It's the same numbers. We've just switched the x and the y, right? So the process is the same. We just end up with a parabola that instead of opening up and down, opens right or left. So how would we graph that? Well, start by finding the vertex. Remember, the vertex is h and k. The most common mistake is people will tell me the vertex is 2, 5. That's actually wrong this time, right? Because the number with the y is not the h. The h was the horizontal shift with the x. This is a k, and this is an h this time. So our vertex is not going to be at 5, 2. Actually, I think I was right. It's going to be at 5, 2. The h stays positive. The k is opposite. Okay? So we go to 1, 2, 3, 4, 5, up 2. And because our a is positive, the parabola still opens to the right. I try not to make these too tricky. If you can complete the square in the homework, you should be able to pick this graph pretty easily. Okay? If you needed another point, you could pick another x value just past that. Past, what was that, 5, you could pick a 6, solve it out, see what you get. Okay? Technically, you could pick a y value 2, you could pick a y value of 3, and see how that works. Not a huge deal. Anyway, but when we look at this, here's basically, in the past I've said, the h is opposite, the h is opposite, the h is opposite. That seems weird. This time the k is opposite, right? And so, if one way of thinking about it, how do I know whether the horizontal or vertical shift is going to be opposite? Well, if the h or k are with their variable, meaning what? The k this time was with the y, it's opposite. If I have y equals a x minus h squared plus k, the h is with the x. The horizontal shift is with the x. It's opposite. When we're about to do a circle, both the h and k are both going to be with their variable. The x will have the h, the y will have the k, and so they'll both be opposite. So if you want a general rule how to tell when something's opposite, if the h or k are with their variable, they're going to be an opposite shift. Okay. Let's do one more. Definitely harder than you're going to see in the homework, but let's see how we can handle this, okay? Step 1. Where is the vertex? No idea. We can't do it like this, right? In fact, we can only do this if a is equal to 1. We need to make that a 1 to complete the square. Which means what? We divide everything by my notes prior said leave the left side messy. Because the right side's going to be messy enough. Oh, you know what I forgot to do? I forgot to move the C. Let me do that first. I like to move that first. So I'm going to move this over, and then I'll divide everything by the negative 2. Okay, so now I have x plus 7 all over negative 2. Left side, like we said, was messy, but the right side at least is ready to complete the square. Please check that both signs change sign. So this one became positive, this one became negative. This is probably about as complicated completing the square as you would ever see, even in your pre-calculus class. That's really the people I'm talking to, people that got to get into that, and you have to be able to handle this type of question. Okay. So what is our perfect square? Y minus half of this. Half of 5 is 2.5. Why don't we just leave it as 5 halves? What do I need to add to both sides? Well, 5 halves times 5 halves would be 25 over 4. And that means I need to add that to both sides. So now we have a horrible, messy left side. But the right side, we've completed the square. So what do? Well, we need to solve this for x. So we're going to move that 25 over 4 over. And if you don't mind, I like to do these steps together. I'm going to multiply everything by that negative 2. So that's going to cancel this left side, leaving us with just x plus 7. The negative 2 goes to the front of this group, so that's basically our a, just like it was before. And negative times negative makes that positive. 25 times 2, 50/4, or how about 25 over 2? Feel free to use your calculator to multiply those if you struggle a bit with fractions. Last step. So that x is equal to negative 2, y minus 5 halves squared plus, common denominator here, 25 minus 14, how about 11 over 2? So how the heck would we graph this? HK. Remembering this is the K, this is the H. So it will be 11 halves, comma, opposite, 5 halves. If you like your decimals, 5.5, 2.5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So over 3, 4, 5 and a half, up 2 and a half. And because our A is negative 2, the parabola opens to the left. I will not ask anything that complicated, but I like to introduce that to you because you need to be able to complete the square. You need to be able to find the vertices. This would be the level of question we would be asking in a pre-calc. And it's everything you've already learned, so don't make it any more complicated than that. Okay, one more big concept, and then this is actually, I think, our last kind of hardest section. The next section I think is a little easier. Let's talk about circles. X squared plus y squared equals 25. Now, we've already given you in the notes x squared plus y squared equals r squared. But I'm going to just say, if I didn't know how to graph this, I would approach it just like anything. I would plug in points. All of these are x values. We can plug them in place of the x, and solve for y. I want one more x value there. Alright, so where are we at? So I'm going to start with an easy number. I'm going to start by plugging in a 0. 0 squared plus y squared equals 25. How about just y squared equals 25? When I square root that, I get two answers. That means this is not a function. Doesn't mean we can't graph it, just means it ain't going to be pretty. If I plug in a 1, 1 squared plus y squared equals 25, gives me y squared is equal to 24. 1 squared is 1, right? So when I go to square root that, the square root of 24 plus or minus the square root of 24. Or, if we wanted to clean that up, that would be, I think, 2 root 6. Neither of those is really helpful to graph. So what would we do? Well, let's use the technology and say the square root of 24 about 4 point, nope, the square root of 24 about 4.89, so about 4.9. Let's try the 2. And I know this is going to seem tedious, just stick with me, we'll get through it. So at this point, though, I am going to be erasing some of them as we go. So we have 2 squared plus y squared is equal to 25. That gives us y squared is equal to 21. So we got plus or minus the square root of 21. Another messy number. Square root of 21. Still in the 4 range. But a little closer. 4.58, 4.6. When I plug in a 3, 3 squared is 9, plus y squared equals 25. That gives us that y squared is 16, so that y is equal to plus or minus 4. 4 squared is 16, plus y squared equals 25. Subtracting that, y squared is 9. That gives us plus or minus 3. 5 squared is 25 plus y squared equals 25. That gives us y squared is 0. When I go to square root that, y equals 0. When I plug in a 6, 6 squared is 36 plus y squared equals 25. Subtracting that, I get y squared is negative 11. The square root of negative does not exist. It's not real. This graph does not exist past 5. That's a restriction on the domain, right? The idea is that I need 2 numbers that add to make 25. The largest number x can be is 5. Anything past that, and 6 would have to be an imaginary number. Okay? Whew. So what happens if I plug in a negative 1? You're like, oh my gosh, I got the whole left side? No, no, no. What's negative 1 squared? Well, isn't that just 1 plus y squared equals 25? I still get plus or minus square root of 24, or plus or minus 4.9, I think is what it was, yeah? If I plug in a 2, negative 2 squared is positive 4. I get the same thing, square root of 21. If I plug in a 3, negative 3 squared is positive 9. I get the same, I get the same, I get the same. And that also means that negative 6 would not work, because the graph would no longer exist. So our graph only exists between negative 5 and positive 5. Alright, so we're going to plot these points. Now the idea of, that it's symmetric on both sides, that should sort of make sense. Because keep in mind, we are graphing a circle, right? So I'm going to go ahead and erase some of this mess, so I can keep my table there in front of me. And let's plot these points and see what picture we get. Okay. So there, and 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. When x is 0, y is 5, and y is negative 5. When x is 1, y is 4.9, and negative 4.9. When x is 2, y is about 4.6, and negative 4.6. Sorry about that. Move it over. Alright. That was a little sloppy. That's okay. Then finally we get some pretty points again. When x is 3, we have 4 and negative 4. At 4, it goes to 3 and negative 3. And at 5, it goes back to 0. What shape are we forming? I'll give you a hint. If you don't see it yet, create the reflection on the other side. These are the same points, just reflected. Right? And this one goes to 4 and -4. This one goes to 3 and -3, and then this one zeroes out. What shape do we have? This is by far the best circle you will ever see me draw. And it ain't pretty, but that's as good as it gets for me. We just graphed a circle. We knew it was a circle. I told you it was a circle at the beginning, see? But if you weren't sure, you could always approach a graph by plotting points. So how do we make this graph quick and easy? Some of you have already known this, and you're like having a heart attack going, oh my gosh, let's get past this. Remember, it's x squared plus y squared equals r squared. What is the r? R squared is 25. So when I solve that, we are graphing a circle with a radius of 5. How far over did we go? How far up did we go? How far left did we go? How far down did we go? This is a circle with a center at the origin, no h or k, no shifting at all, and a radius of 5. So everywhere along this, these are values that give us a radius of 5. We're going to do another one of these. I am not going to make us graph it the long ways. Just be patient. So how about x squared plus y squared equals 9? We'll plot some points. No, right? This is x squared plus y squared equals r squared. This is a circle. There is no h or k, so that means that the shifting is 0. And the radius, if r squared is 9, then r must equal 3. So how would I graph this? Starting at 0, there's our center, go 3 to the right, plot a point, go 3 up, go 3 to the left, and go 3 down. And what shape is it? Draw a circle. I told you my circles suck, right? So that's the idea. Just find the center, and then plot the radius around that center, and you should have your shape. Again. Now this one's different. It's been shifted, right? Don't freak out. This is an h. The number with the x is our h. The number with the y is a k, just like it was before. But keep in mind, they're both with their variable. The h is with the x, the k is with the y, so the shifting, both are opposite. Both the h is opposite and the k is opposite. So we have a vertex at, looks like 2, -4, or not a vertex, a center at 2, -4. And then from there, we have a radius of, hopefully you know, it's not 16. If you plot 16, you're going all crazy, right? R is not 16. R squared is 16. What number squared gives us 16? R is 4. So that means from that point, to graph the circle, I would go up 1, 2, 3, 4, and plot a point. Go to the left 1, 2, 3, 4, and plot a point. Go down 1, 2, 3, 4, and plot a point. And go to the right 1, 2, 3, 4, and plot a point. And then draw a circle. Gosh, my circles suck. Centered at 2, -4. I can do better than that. Centered at 2, -4. That's bad. But, alright, I feel better about that. And I know I shouldn't. With a radius of 4. Circles are easy to graph. Where do they come from? Well, plot points, and we can see where they come from. But past that, we use the h and the k, and we use these things to make the graphs easier. That should be it for the homework. I do have one more thing I want to show you. Right here. Because this, if I asked you to graph this, how the heck would we graph it, right? It is not in shifted form. We don't know h and k from this. So what do? Skip it, right? No. By the way, you can't do this. You cannot do this using a trick. You need to know how to complete the square. So what we're going to do is I'm going to group the x's, leave some space for c. I'm going to group the y's, leave some space for a c, and I'm going to move the current c, the current last number, so that I can complete the square for both of these. What's my perfect group for x? Half of 8 would be, so we add 4 times 4, but what I do to one side, I do to the other. What is it on this side? Well, let's see, how about y minus 1? That means they're adding, looks like 1 to both sides. So we get 2. That's it. That's what we're terrified of. It drives me crazy that people are terrified of completing the square. This is it. You just move the number over, complete the square for both of them. So what does this end up looking like? Well, it's a circle with a center at -4, +1, and a radius of not 2. Square root of 2. Ain't going to be pretty, 1 point something, but the idea is that the radius will move 1 point 1 point something from that center. That's it.
And our last graph that we need to look at, our last graph type, is called an ellipse. We really did save the easiest for last. I could just show it to you, but I do want to go through and actually understand. It's very similar to a circle. An ellipse is basically a complicated word for an oval. The difference between this and a circle is we don't have just a radius, we have radii. That is the plural of radius. We have differing radii, and if you're not sure, we can basically plug in numbers, and I'm going to focus on just kind of 4 numbers that are going to give us an overall shape of what an ellipse is. Let's go ahead and start with x. So I'm going to go ahead and pick an x value, and the key on this is that it is set equal to 1. So what value of x would make this first thing a 1? What squared divided by 4 would be 1? Well, 4 divided by 4 is 1, so that would work. X would be, this whole thing would be a 1 if x were 2, or if x were -2. Why? Well, 2 squared would be 4. 4 divided by 4 is 1. Why is that important? Well, because I end up with 1 plus y squared over 9 equals 1. 1 plus what is 1? Well, this whole thing has to be a 0. So the only way, if x is 2 or -2, then y must be a 0. Why? Because whatever makes this 1 must also make this 0, so that 1 plus 0 is 1. Well, we've got 2 points there. We've got 2, 0, and we've got -2, 0. I can do the same thing with the y. I can think about this and go, okay, well, what would make that y turn into a 1? What squared divided by 9 would be a 1? Well, if y were 3, or if y were a -3. Why? Because that would give me x squared over 4 plus 3 squared is 9 over 9, or 1, equals 1. Well, if this is a 1, then that means x must be a 0. So that gives us two more points, 0, 3, and 0, -3. These are our radii. Basically, we have kind of a minor radii, where on the x-axis it's 2, and on the y-axis it's 3. Okay. What is the overall shape? Well, it's still circular, but it's more like an oval, because the radius changes. So like I said, this is kind of just plotting some points to think about it. This is not the way I'm going to do it. Basically, I have x squared over a squared, y squared over b squared, a. We say, well, what squared gives us 4? Well, a would equal 2. That is the radius on the x-axis. What squared gives me 4? A is 2. I go right and left 2. The b, what squared gives us 9? Well, b would equal 3. That is the radius on the y. A couple more examples. This one is not in the right form. Because remember my notes that I just copied down, we said I want x squared plus y squared. I want it standardized. We want it set equal to 1. Because we're going to have two different radii. We're going to have two different radiuses, I guess radii. So I need this set equal to 1 so I can see what is the radius on the x, what is the radius on the y. How would I do that? How would I get this set equal to 1? How would I get it back in that standard form? We'd divide everything by about 100. 4 over 100 gives me x squared over 25. 25 over 100 gives me y squared over 4. And 100 over 100 is 1. We have now standardized this graph. So I can figure out what are the radii. Well, the radius for x is a. So if a squared is 25, then the radius on the x, a must equal 5. So from the center, I would go right, 1, 2, 3, 4, 5, and I would go left, 1, 2, 3, 4, 5. All right. What about for the y? Well, b squared is 4, so that b must equal 2. So I will go up and down 2 on the y-axis. This is my a. This is my b. What is the overall shape? Well, it should be shaped like an oval. With a radius on the x of 5, a radius on the y of 2. Okay? One more. Why is this one different? Well, it's shifted, just like we said they would be. We have what? X minus h squared, over a squared, y minus k squared over b squared, set equal to 1. This is ready. And you're like, well, what's our a? What squared gives me 8? Well, it ain't pretty, but there's a number there. It is what? Well, if a squared is 8, then a is the square root of 8, or 2 root 2, or I think it's like 2.71. It's a complicated, kind of messy number. But so our a is approximately decimal there, right? I should double check that before I just accept it. What were we looking at? Square root of 8. 2.82. 83. See? Alright, so that means that on the what? On the x, we go to the right, 2.8, and to the left, 2.8. On the y, you're like, well, there's no number there. Well, yeah, there is. It's over what? Over 1. So if b squared is 1, b must equal. So we go up 1 and down 1. This is what that graph would look like. Only problem is this. This is not our final answer. Well, why? It was shifted h and k. Remember here, both the h and the k are both with their variable, so they're both opposite. So we figured out the parent graph, but we have to remember to shift this graph opposite, 1 to the right, and 2 down. I literally can take each of these points and I can move them. 2 to the right, no, 1 to the right and down 2. Take this point, 1 to the right and down 2. Take this point, 1 to the right and down 2. Take this point, 1 to the right and down 2. So that is one option. The other option is this. I could actually call this shifting. I could call that my center. So I could call 1, negative 2 right there the center, and then I could build the circle around it. I could go left and right the 2.8, and I could go up and down the 1. That's generally the way I do it. So you can either build the parent graph and shift it, or I could build the graph over our shifted center. So kind of pick your poison on that. But that's it. So the ellipses are not kind of the hard ending of this. The shifting is still the same. The skills are the same. This will be on the test. This will be on the final. So get studying. I'll see you guys soon.